Well, hi, good morning, and thank you for joining me in my shop here today. It's November 4th, a gray, rainy day here. Lots of this happening. Last winter, we went the whole winter, we hardly saw the sun all winter long, and it looks like the same thing's starting to happen. It's just gray, gray, gray. Okay, well, let's blow the gray away here. How's that for a segue? That was fantastic. More capacitors got to go. We got to pick which ones to do next. So far I've done the two grid blocking capacitors with probably minimal impact on the radio's operation. The radio was producing a hum. I think it's a hum due to a rectified 60 cycle signals, really what I think we're hearing. So it's like 120 hertz buzzy hum. It seemed to disappear after I did the second capacitor. Although when I was putting the video together, it struck me that the hum had disappeared earlier than that. So I don't really know what to make of it. Perhaps I just couldn't hear the hum on the video because I didn't have the volume up too high. But it looked like yesterday changing the volume control capacitor got rid of that annoying hum, and that made sense to me. Except I have an observation which suggested it already disappeared. Anyway, I'm going to go with what it appeared like yesterday. So, radio's operation's pretty good now. Maybe we should play it some more and try to pick up on some problems that we can then try to resolve somehow. I think I'm going to take this out of here. Lay it down. We'll give him a good run for his money here. And maybe we'll have a listen to the Shortwave band too. Why don't we start by considering the light bulb situation here. So yesterday I put my hand on the side of the radio at one point and I reacted from the heat there. The heat coming out of the resistor that's mounted right here. That resistor, this portion of that resistor, is paralleled by the light bulb. So I took a look at the light bulb situation. Now the radio wants a number 47 light bulb. Turns out the hot filament resistance is around 40 ohms, which is a similar resistance to the resistor it's across. 40 ohms. So I haven't been able to find a 47 light bulb yet. But I do have a 51 and a 55. Now the hot filament resistance of those is only 7 ohms. That's way different than 40. So it looks to me without the light, the resistor is getting hotter than it should. With the correct light, just enough current is going to be split between the resistor and the light to cool down the resistor and have everything operate properly. If I put in the 51 or even a 55 light, the result of that is the resistor will cool right off because a lot of the power will go through the light bulb, and will boost the voltage in the radio slightly. Probably better to heat up a light bulb than to heat up this resistor. But 7 ohms, so you're going like 40 and 40 in parallel is 20. But 40 and 7 in parallel is 5. 5 and 20, that's a factor of 4. That's a big difference. I think I'm going to just take a little bit of time here and try to scare up a 47 light bulb. I should have them. I have LED versions of them, but you can't put an LED light into this situation. No. So I rechecked my numbers here for a number 51 light bulb, and this is the Microsoft Copilot page that you're looking at here. And down here, so we're just going to be scrolling through what I've already done. So I asked it first of all, what are the ratings for a number 51 miniature bulb? But unfortunately, I didn't push the shift. What's a 351 miniature bulb? And it answered the question. 28 volts. Well, I don't care about that. So give me this chart, all this stuff. But then I said, I meant a number 51 bulb. And it says, got it. 51 miniature bulb typically has the following ratings. Voltage 7.5, current 0.2 amps, power a little more than 1.5 watts. Bulb size. Okay, but what I need to know is the resistance. So I then asked it this: what is the hot filament resistance of a 51 bulb? And it gave me the answer. The hot filament resistance of a 51 bulb is around 30 ohms. That makes more sense to me than the 7 I got last night. I think I must have typed something wrong, or I was asking about a 55 bulb. Let's ask. What about a number 55? Because you can have conversations with this, you don't have to like repeat a lot of stuff. It knows where you're coming from when you ask these things, just like a person would. 7.5. Okay. And the hot filament resistance? So look, 18 ohms this time now. Maybe this is a case where you don't know where it's getting its information or how it's doing its thing here. I'd love to hear more about it. Yeah, you don't love anything. You're a machine. Don't fool with me. So here we are. So we go back to the 51 bulb. What we get is hot resistance 30 ohms. That's perfect. That's fine. I'm going to put a 51 in there, and we're not going to sweat over it anymore. Okay, so I found a bulb in my collection here. 1847 is the number on it, and I wondered. So I asked Mr. Bing here, is the 1847 bulb the same as a 47 bulb? And here's what it said. 1847 bulb is similar to the 47 bulb, but there are some differences. Both bulbs at 6.3 volts. 1847 bulb has a lower current rating. This is curious, 0.15 amps compared to the 47 bulb, 0.15 amps. You got the same number, so this sentence actually doesn't make sense. 1847 bulb has a power rating of about 1 watt, and the 47 slightly higher, 1.2 watts. Average life of the 1847 bulb is a longer average life, 5,000 hours, compared to the 47 bulb. Here it is. The 1847 bulb is often used as a longer lasting, cooler running substitute for the 47 bulb. And then it asked me, are you considering using one of these bulbs? It's none of your business. You're a stupid computer. Okay. I think I finally got a bulb. Didn't I say something? Okay. We're done with the bulb issue. Okay, I think we're ready to try it all out. Plugged in. Switch is on now. Here we go. Oh, did you see the light? The light really blasted on there at first. You may not have seen it. Let me look. Oh, I see. Yeah, the bulb is actually blocked from your view here. So you missed the exciting initial flash. That was quite a flash. Not surprising. The vacuum tube heaters are cold. The resistance is very low at the start. So the bulb gets a whack. I think some people think the bulb takes the whack and the heaters don't. And I guess there's a little bit of truth to that. But that's not the intention of the light bulb. I don't think. I think the intention of the light bulb is to light the radio. Okay, well, we're hearing something already. This is the French broadcast station. A lot of interference, probably local in my house here. Let's see if it isn't these. Nope. Okay, so a couple things on the antenna. So you can connect the ground to the chassis. Oh, isn't that a lot better? Let's leave it like that. Check it out. Good antennas make bad radios sound good. Oh, there's that buzz. Oh, coming from here. I'm going to put a little dab of oil on the volume control shaft here. Well, that sounds pretty good, doesn't it? Just makes it a little easier to turn. So we don't know where this is in terms of, you know, is it in the right spot here or not. But what is that? Somebody's record is skipping. Nice sound.
$5,000 lower it was at the midpoint just last week. And Trump media stock is down just before the bell here, right now by about 2%. It was.
About her nicely, you're still talking about her and her candidate. So I guess that's what they say is the advantage. We'll keep an eye on that.
Even here in Canada, the United States is the big news in their election.
He's not afraid of the smoke that's going to come with that ask. And yeah, he's volunteering to be on the penalty kill. It's something that he's done
At the
before.
sports channel.
Some pride in it.
Lovely. This radio's working great. Why would I want to do more to it? Okay, let's try the shortwave band. Let's see what happens here. Now, the shortwave band is, I think it was 18, wasn't it? Was it, what was it? What was it? It is 9 megahertz to 15 megahertz. It should really go to 16. So 9. So let's go up on the top end here because we're almost there. Ooh. Not too good on the reception here. Different antenna? Would it be a different antenna? Let's tune around a bit. There's nothing. Nothing. So what is this other wire? Well, it's not having an antenna effect. There's another one coming here. This one, oddly enough, this wire goes right up to the speaker voice coil. So this is a way to get another speaker onto this radio. Really? That's really bizarre. Can't say I've ever seen that done before, and I'm sure it's original. The other voice coil terminal is grounded to the chassis. So, well, okay, so that explains this wire. There's actually 4 wires coming out here. This one is going right to the chassis. This one is going down under to an antenna coil underneath. This last one, I don't know, what the heck is this? It's like there's nothing happening here on shortwave. Nothing at all. If I got this turned up, maybe I don't have it turned up. Oh no, it's full. Okay, go way down the other end. Just nothing at all. So dead, could be. Band switch just never made contact. Take the one knob and put it on there. Doesn't seem to be the case. Seems to be fine. No shortwave at all. Well, we should take a look and see if there's a local oscillator oscillating in this radio. Interesting. Interesting. Okay. I will set things up so we can take a look for the local oscillator. Okay, so just a minute's gone by. While I was starting to get things ready, I noticed the hum is back. The hum. And I got the volume up pretty high. Ooh. More hum at a lower volume. The hum is gone. Everything is gone. There's nothing here anymore. Oh yes, there is. Oh yes, there is. Oh yes, there is.
West 401.
What's going on with this thing? Let's go back. just a matter of cleaning this control and it'll stop that. Stop that. So it's intermittent. That's how I got fooled last time around. So this is warm, but not. I don't think it's as hot as it was. But maybe I gotta let it run longer. Didn't I already hose this control? Maybe not. Who's in here? Okay, so. Ah, here they come. These two guys stick together all day long. Where one goes, the other goes. And they play and wrestle and they just don't stop until they're sleeping. And then they sleep in a little bundle. And away they go again. All day play. And investigation. I like investigation. Hey, get off of that. Come on. Yeah, okay. I can't keep up with him. He's an action cat. He's looking for trouble. He's bound to find it. Yeah, I think so. Okay. Now, as long as I don't step on you down there, I'm going to flip this radio over. You know, I don't think I sprayed anything in here. Just going to let her rip right where the terminals come out here. I don't know. Try this one. Ooh, that was a good blast. I think that must have gone in. Okay. Now there's a lot of things you can do to a radio, like the stuff I just did. You can do a lot of things to a radio before you ever turn it on. But how are you ever going to know what was going on with it? And how will you ever know if the things you're doing are actually good things or bad things? So that's why I like indications before I do stuff. In case you're wondering, well, why didn't you clean that volume control right at the start? You could guess it's bad. I suppose the capacitors charging up. No, they won't. No, they won't. I was going to say the charging up of the power supply capacitors puts a big poke on this light, but that's not the case because until the rectifier heats up, there's no high voltage to charge the. Yeah, so that didn't help much. So I think the moment it stops, it's losing contact. It's not an improvement. It's the opposite. So the hum is still there. But wait a minute. Whoops. Yeah. So I did not get rid of the hum. Okay. Got that straightened out. So this hum could be one of the tubes. It could be coming from a tube heater. It could be a heater at the cathode short or something. It could be a tube. No amount of capacitor changing is going to help it. But, okay, let's go back to the shortwave band where we're hearing nothing. Still. A bit of dirt in the tuning capacitor, maybe. Don't know what that is. Didn't pick up a thing. Oh yeah, we were going to look for the local oscillator. That's right. Okay, I'm almost set for that. It may well be the case that the fact that I can tune in this, whatever this is, well, whatever that may indicate the local oscillator must be operating already. The only thing that's being varied, really, when you turn this control is the local oscillator frequency. A little bit of tuning in the front end, but so if something happens because you are turning this, it has to be because a local oscillator is doing something. So let's take a look on the SDR in any case. Here it comes. The SDR pickup coil is near the mixer tube, I believe. Okay, so, and we're tuned to around 15 megahertz at the top of the shortwave band. I'm now going to tune the radio, and we'll see if you can spot one of those things as the local oscillator. Oh my, everything's on the move here. So this is a common thing I find with all these radios, super heterodyne radios, is there's a lot more junk going on. You see, all this stuff doesn't mean anything unless it results in a 455 IF frequency. That's the only thing you hear is the 455. So there can be all kinds of signals running around in these radios. Oh, did it just start working? No, I think that was just another kind of interference there. So it seems like it's working, but it's really weak. Hey, what if I take that antenna ground off? There's nothing more to see on the SDR here. Yeah, what happens if I take the ground off? That's weaker. Oh. What is that? It's picking up stuff, but it's weird stuff. Well, let's go down to the low end here, which was 9 megahertz. We're going to look for the local oscillator down at the low end and see what we can find there. Okay, low end would be around 9. We'll go down there. So we would be anywhere here. Tune the radio now, and just everything is on the move. But you see, right around the 9 megahertz spot, and notice the radio crackles, and then the thing right around the 9 megahertz, that's right around here. This one. This is the local oscillator, I believe. Strongest thing on there. Watch what happens to it when you listen to the radio and watch it. So this suggests to me that the tuning capacitor, the section that's controlling the local oscillator frequency, is shorting out. So I'm just tuning up. Up. So this is pretty weird now, but wouldn't it be? I'm up where my frequency wise. Just looking at the dial and figure I'm around 9.5. So that would mean around 1 million you'd find the local oscillator. And these weird, some of this weird stuff you see, you know, I don't know, is it my SDR? Is it like just these weird patterns? Really cool on the waterfall display. We're just going up in frequency. So, okay, so supposedly the local oscillator is at 10 megahertz now. I'm guessing, and it would be about right, looking at where the dial is. So, all these wild guys that are flying around here, none of which we hear, by the way. Nothing is coming out of the speaker. Until you get to this spot. It's strange. Look at how they all come together right there. I'm working the tuning knob back and forth. I'm sure someday I will understand exactly what these are, but I still don't. But they are fun. They make nice artistic work on the waterfall display. Okay, enough fooling around. Yes, I like to fool around. Let me go back to the camera here. So, okay, works really nice on AM. Seems to be a dog on FM, on shortwave. Has that hum. Gotta be, hopefully, from one of these capacitors. as I said, it could easily be a tube itself causing that. Notice when the volume control separates, the hum disappears. So that would suggest to me the hum is coming from earlier stages. What exactly would it be? I got no idea, really. Not exactly. Okay, I'm going to stop for a little bit. We'll look at the schematic and we'll pick on a capacitor and just start going through them. So we got two things to think about here. One is the hum, or buzzy hum as I call it, that's coming out of the radio. And the other one is all the stuff we saw on the SDR that seemed to be present when I changed the local oscillator frequency. You can see all these things moving around. It strikes me that that stuff should probably be snuffed out at some point, and it's not being snuffed out. And in fact, what it really is, and again, this is just me talking, I don't know that this is really the case, is the output coming out of here is finding its way back into the input. And then what's coming out of here is being remixed against the local oscillator, actually here, local oscillator, and the result is another whole set of weirdness which goes through and comes around again. I don't know for sure that that's what's going on, but if that's the case, then there are capacitors that are supposed to stop signals from working their way from the loud part of the radio to the sensitive part. One of them is right here, great big 0.1 right here. Another one might be this 0.05 here. Could be having this kind of effect, allowing signals to make it all the way back to the front. This guy here, he has some special purpose, similar in a way, I think. The problem being that the big filter electrolytic capacitors don't work well at a higher frequency. So sometimes they like to throw in a capacitor like this. Now maybe I'm wrong about this. This is not in parallel with these guys. It's doing something slightly different. But nevertheless, here's the outlet where there's 60 hertz just blazing away out here. That's not far from this capacitor, so it's crazy thinking. But maybe this one too. And there could be more in here that could have an effect on that hum, or an effect on the can we call it feedback? I'm not even sure what it was we were seeing on the SDR. So I think this is probably the first guy to go after, this 0.1. It's going between the B minus line here and it's not doing what I thought it was doing at all. It's a cathode bypass. Okay, we're not going to go after that one right away. I don't think this one can have any influence on either of the things we just talked about. So we could go after this one. Or, look at this one. So here's another important one. So these are screens here. This is the screen circuit. Screen, grid, and that capacitor is tied down to what is this? It's tied to the B minus. And which one was I pointing at? Was it this one? I think it's this one. I don't know, clearly. Let's see if we can do this one first. This is, I think you can call this the AVC capacitor. Number 24. Let's see if we can find 24. It should be easy because I have a chart here. There's 24, kind of near the volume control here. Okay, let's look in the radio. 24. So that would be it there. And it's just connected on this terminal strip, nice and easy. Okay, so we'll do that one. We'll do that. Yeah, I'm pretty certain to be on my way to changing all these except for this guy. Maybe leave this one. It seems so dark in here. I don't understand. Two outside terminals. Why would it seem so dark in here to me today? Whoops. Oh, where'd it go? It disappeared into the radio here. It's trying to hide from me. So we're going to put this guy on the tester right away. Is it a 0.05, I think? Yep, 0.05. Good looking capacitor. Okay, I'm just watching my cats in case you're wondering why I'm quiet. Kittens, I guess. Okie dokie. 50. What do you do? Close right up, not opening. So I know this guy's a leaker. No surprise. Bad leaker. Occasionally I'll do that test on one of these old capacitors and it'll the magic eye will open right up, like it. Flip a switch and open right up like that. And that's because the capacitor's capacity has fallen to nothing, probably because the lead is separated from the foil inside. I've had a couple like that. Okay, I'm going to put in the new guy here, and we'll try the radio and see if any of those weird things went away. Okay, let's start up the radio here, and switch is on. Plug in. There we go. Much better with the light. The light keeps reminding me when it's on. And I say that kind of jokingly, but no. Just when the camera was off and I was doing the installing the last capacitor, I started working on the radio with it plugged in, with the power still switched on. But nothing happened. Lucky me. Okay. Is it better? Oh, I don't have the ground connected here. Let me connect the ground wire. This is going to be a little better. So I didn't really make a note of it, but you can tell the AVC is working well. Is that right now? You don't hear much noise in the background. I'm going to tune off, and you'll hear the noise as the radio becomes more sensitive. There it is. Exciting. Not very exciting, but the noise disappears as I tune it in. Should have probably made that observation ahead of time. You know what else I just noticed? There are marks here. One here, one here, 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 and here. These are probably registration marks for the alignment process. When I get to that, so I don't need to put the have the scale on. Okay, what happened on shortwave? Did anything? I wouldn't imagine anything changed. Just a hum. So, just that weird noise. Nothing. We've still got nothing going on here. I got the ground on. Let me take the ground off. Try again. No different. Oh. There's a little bit of a hiss there. So it's picking stuff up, but barely picking it up. Why would that be? It could be an alignment issue. Let's go down to this end. A lower frequency end here. Seems to be a spot where it's working and nowhere else. Right in here. So it's just very, very low volume, but it seems to be receiving up in this end. Okie dokie. Well, let's take a look at that question. What could be wrong with the shortwave that would not be wrong with the broadcast? So we'll take a look at the schematic and ask that question. The question is, what's wrong here? So let's go back and take a look at what's going on with the front end of the radio. When you have it set to broadcast, right, the switch is currently set in broadcast position. So we can look at these switches here. We can see, let's see, the loop antenna, one end grounded to the chassis, other end here connected here. Oh my gosh, what a complicated schmozzle. What's all this for? Is that connected right there? This must be a transformer working this way. 1, 3, 4, 3. This must be a 2. This must be the number 2. There's a 2. 1, 2, 3, 4, 3. Okay, well, assuming this is a transformer then we have the shortwave antenna terminal connected through this capacitor, energizing this coil, and then transforming the signal over to here, and then it's right into the grid. So this antenna is missing. Consequently, this wire connection is protruding from the back of the radio, which I believe I've connected to. Or did I connect to this? Which is which? What is what? Which is what? We gotta look at those wires again and figure out what they are in their entirety. I think that amounts to one wire, knowing where this one wire goes. I don't know where it goes yet. So make sure we're feeding in the shortwave antenna signal into the right thing. If we're feeding it into here, it just may not, like if I've hooked up to, I don't know, somewhere to what? I don't know. There's nothing here to hook up to. If we flip it over to shortwave, then this switch flips. Let's work from the grid. So we come back this way. No matter what, this is always operating. There's a cat crawling up my leg right now. He gave up. We get to here. This is where the switch happens. So we switch it here during shortwave. This gives us this tuned circuit here. I wonder what this is. Number 5. So this is a trimmer, I think, because it has the arrow on it here. So I'm not exactly sure what you're tuning this for. Could be IF frequency trap. I don't know what it is. And so let's go back up. So wait a minute. So we're coming down from here. We could be coming down here. If the switch was thrown, we would be picking up a signal This is the tuning capacitor, and we'd be picking up a signal from, what's this all about here? Oh, there's a cat climbing up my leg. Oh, 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 it's got all the way up. Okay, I've got to go to the camera now. Cat on the bench. Getting on the bench. Power off. Power everything off. Getting on the bench. Oh no. Now I'm in trouble. So he got up there by climbing up my pant leg. And this guy's name is Bert, which is, there he goes. That's enough of that. Okay, he's not into electronics. Good. Bert. So we named our cats kind of in memorial to our cat Peanut, who passed away about 6 months ago. So we've named them both nut names. So one is called Wally for walnut, and he's called Bert for filbert. Filbert is a type of nut. Isn't that exciting stuff? Okay, I've totally lost what I was doing, so I'm going to stop now for a bit and have a little break. Darn cats. Okay, let's take a look at this. My head came apart trying to sort out what's going on in this radio until I've colored this up, and now that I've colored it up, I'm still just as confused about exactly what they're doing here. So the most interesting thing, and let me explain what I've done. The red dots are the AVC voltage being applied to the grids along here, along these paths. Interestingly enough, I don't want to get into this right now. If you follow this AVC line, yeah, it goes to the grid, but it also goes up to the suppressor grid, which is weird. I don't know what's going on there. That's something I've never seen before. The orange, which is a little hard to see, the orange is the signal path when the radio is switched to broadcast. That's pretty simple. Coming from the antenna here, along the switch, into this coil, through the capacitor, onto the grid. There you are. And here it's getting its AVC voltage this way to affect the gain of this. So that's what's going on with broadcast. It's simply from the loop, in. That's pretty straightforward. Then would come out of this tube, go through the IF, go through an RF. Okay. Okay, so, lights just came on here. I thought maybe if I did this on camera, the lights would come on. So I'm thinking this is an IF transformer, and it's only being, and the switch is switching. What? No. These are the IF transformers. This is a fancy RF transformer after this RF tube, ahead of the mixer tube. See, when you switch it to shortwave, and the blue indicates the shortwave circuitry, which we're going to go through in a moment, this switch here switches the signal grid in the mixer tube from the original source, which is the broadcast band, up to here. So goodbye to this and goodbye to this. This is doing nothing when you switch to shortwave. It's a big change. You're now connected up here. If we follow this back through a capacitor, down, and then things get a little weird here. Oh, I'm going to have to stop for a moment here. Oh, I got distracted there. No. What was I was just talking about the strangeness that the AVC voltages presented to the suppressor grid, and I was just starting to track the shortwave path, and I was talking about it going around this. Like, this is just for the broadcast band, which is kind of blows me away a little bit, because a tube like this is extremely useful on shortwave too. So this is like radio's built for AM radio, and shortwave's a secondary thought, I guess. I don't know. So anyway, let's follow it back. So okay, so we switch. Switch is now here. This grid isn't seeing anything from here. It's all coming on this blue wire. This other circuit here with the 1 meg resistor here, this is the AVC voltage being Uh-oh, this is B minus. B minus. Well, they're applying a ground here. I don't know what they're doing, okay? I did say at the start, I never really figured this out completely. Well, let's ignore this. I think it's just a way of getting you know, I ain't got a clue. I should shut up. Okay, we'll follow this line. Go down here. Things are getting weird now. So in broadcast position, this switch is open here. But in shortwave, what we're looking at now, the switch is closed. This is the tuning capacitor, the main tuning capacitor. And you can see, if you follow this line up, on broadcast band, it's working against this coil. On the shortwave, I don't know what it's doing, really. I don't know what's going on here. Is it trying to catch this signal and bring it down and feed it through and send it back up and over? Maybe that's what it's trying to do. So when the switch is open, none of this signal can make it over here. And this switch is also open at that time. So it's on broadcast. This whole piece is just out of here. Is that right? Is that right? So yeah, this switch is open. Oh my God, I'm confused. What happened to the focus there? Oh, hopefully it wasn't out of focus for a long time. I just looked up at the TV there. Okay. Well, let's just keep going. Just keep going. Never mind this. So we go this way. We're heading for the antenna here. We see this thing, which I don't know what this is. It's probably a 455 trap, but I don't know. And then we go up here. Now the switch is thrown, so the switch is here. So now we're heading this way. We're heading for the loop. Well, not really. We're heading for this. So conceivably, this is where you would hook the shortwave antenna. Your long wire antenna would be hooked here. There's no other terminal available for it. And it says antenna. I believe this is the wire that I've hooked up my antenna to, and I've listened to the broadcast band by feeding in here. How would that work? If I'm feeding in right here, and I have the radio in broadcast band, then this comes down. There's no switches or anything. It goes right through this coil to the chassis. Which is probably why when I hook the ground up, things get a lot better. When I hook the ground lead from my antenna supply, the black lead, the radio operated a lot better, because probably I'm energizing this coil properly. Then its signal is ending up in this one, and then it's on the grid. What happened there? So no matter what, whatever you hook up to this antenna is going to energize this coil. But if you have it in short wave mode, same thing's happening. Signal coming down here, energizing this coil, ending up in here, and then coming this way, but the output is cut off here. So the fact that the signal's here doesn't matter. What this tube is doing doesn't matter in short wave. Instead, we seem to be grabbing it here, sending it through here. So what's this switch doing? So now, so this switch would be this way. That would open this tap here. There'd be nothing, no tap. This coil would just be saying, what's this coil doing anyway? It's just part of the secondary of this transformer. So it would still do the transformer thing. And this is the weird part. No, it's not the weird part. Yeah, it is kind of weird. Because this connection connects to this. What's the purpose of this? This gimmick they've got here. Gimmick is here in case you want to use a wire antenna on broadcast, because then you could, some of the signal would be stuffed into here and into here. That's what this must be. So if you want to augment the loop antenna, you can. You can give it a try. This is how the signal's going to go through there. Come down. Am I ever going to figure this out? So what I'm concerned about is the radio didn't work on shortwave well because I don't understand how to hook an antenna up to it. That's what I'm trying to sort out here and convince myself. There's really only one place to hook an antenna, and it's the wire with this coil on it. I know which wire it is. It's the one I hooked the antenna to. So what's going on with all this? And man, I don't know, but the bottom line is this whole circuit is just for broadcast. Probably why this radio works real nice on broadcast. Well, then we lose the advantage of the RF tube going to shortwave. And instead, basically, the signal here is stuck on the grid here. And there's a capacitor tuning against one, I guess this coil. I'm not sure. Okay, so now it raises the question, so why isn't this working? So what would stop it? If basically the signal is getting there through this transformer, through this backdoor wire coming back this way. And so what? And so what would weaken it? What would weaken it? Defective switch? Open switch, not making it. Capacitor here open, or just not doing its job. Not very likely. It's a picofarad capacitor. It's probably fine. This guy here, don't know what he's doing. Don't know what this is. What the heck is going? Don't know what's going on here. Wait a minute. I do know what's going on. He has to pass the whole signal, if my understanding is correct. Signal coming through here, down here, around, up, has to go through this capacitor. So there's another possible bad capacitor there. And these would only affect the short wave. What else could be wrong? I misinterpreted this, and I never had an antenna actually connected. How could I make a connection that is guaranteed to be correct? It has to be correct. There's just no option here. There's no switch. This is just hook it up here, and you're pumping through this guy here. And that's what I did. And shortwave, did I hook up the ground on the shortwave to see what would happen? And the ground. Now let's just think about that. So it's showing the chassis. So it's coming back through that capacitor, this one here with this coil. Could even be a weak oscillator. It could be a weak local oscillator too. The radio's just not oscillating strong at the higher end. Well, I've got no notion here. I've got no strong notion of what to do next. So I think where are we on the clock? Oh my gosh. Well, that clock has not been corrected. But it's still late in the morning. I think I'm going to stop at this point and just ponder. I mean, basically lick my wounds and go play with some cats and maybe listen to the radio. Listen to some radios. I'm having lots of fun listening to radios these days. Yeah, I'm going to leave it like this, and tomorrow we'll start up again. So sorry, not too exciting a video, but you know, I don't plan. I can't plan these out. This is live, so. Thanks a lot for watching anyway, and hopefully I'll actually do something tomorrow. Thanks for watching. See ya.